got some bus bars from copper pipe. I was looking online for copper strip or copper bar. It's really expensive for what you get, and this is just the easier work method. So I picked up some, I think 3 meter copper pipe, 15 mil, and I'm gonna basically squash them down into a strip. And the reason I'm doing this is twofold. One is it helps with amp draw. So obviously nickel isn't the most conductive of elements, copper is. So at the main positive and negative terminal, it helps me to maintain the amp draw coming out from the whole pack. And secondly, because it has a higher thermal conductivity, any draw that's happening at the main terminals, if it does get hot or warm, this should help somewhat dissipate the heat. Ideally, when I've got these copper tubes, what would be best would be to have a 12-ton press. I don't have one, so I'm going to have to do the more caveman method of squashing these down manually and then fitting them to the pack. Let's get to it. What we have now is 2 copper strips. It's about maybe 2 mil in thickness. So this should be relatively good. That way, one, I can drill into here somewhere along the line and wire in the BMS with a mechanical connection. And then I can obviously, what I'll do is I'll clean this up using a sandpaper and a sander just to get the raw metal and none of the hammer bits, I guess. And then that way I can solder in wires which I'll connect to the main positive and negative, and that way we have a secure connection as well as a connection that helps with the overall thermal properties of the pack. So that's it. Let's go over to the battery pack now, add these in and then go from there. So what I'm going to do to join the 2 halves of the pack together is use some of the nickel and just cut basically strips like this across there and then just keep going up. So probably about 8 to 10 strips should be fine, and then I can spot weld these to the pack, and that way one half of the pack is connected to the other half and I can start working on the BMS. So the parallel connections have been done. I've used 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 strips to connect the 2 halves together. That's all good. So I'm going to quick check to make sure the whole pack now equals to about 84 volts, which is a fully charged 20S pack. So currently the pack is upside down. So if I go to here, which should be positive and main negative, should be at 82.3 volts. So that's all good. I'll start insulating everything and getting ready for the BMS to go in. So what I'm doing now is using a acid flux. So this is a liquid that you kind of brush on. It really helps with the soldering. I'll use the same
acid flux on the copper bars and using a torch instead of a soldering iron to get the metal warm enough and hot enough for it to actually melt the solder itself. And that will be coming up in the next scene. So this is the final wiring. So you've got the BMS here on the negative pack, BMS itself, that comes through the main output, and you've got these two lugs. One is for the main negative, one for the main positive, and then you've also got the charging port, which I'm not sure what port this is, so it's quite a solid connection here. And then in terms of the BMS, what we also have is the thermometer. So these are two thermal probes that are positioned in terms of the battery to measure thermal load. And then you've got the on-off, main on-off switch here, which is wired to a momentary switch here. So if I switch that on, you should see the BMS comes alive. So I'm going to start wrapping this up now. Final installation.